Today we are going to begin Unit 4 and we are going to be talking about inverses. So let's talk about some inverses with which you are already familiar. Think about that for just a second. Think about the word inverse. Are there any inverses that you are aware of already? Well, I think you'll be surprised if you did not think of one to find out that you actually know quite a few inverses. The inverses that you're probably already familiar with are inverse operations. For example, multiplication and division are inverse operations. If you multiply a number and then divide by that same number, they undo one another, and that's what inverses do. Another one you're probably familiar with is addition and subtraction. So if you add 5 to a number and then you subtract 5 from that number, you undo what you had done. They're inverses of one another. These are things that you use to start solving equations when you were in middle school. You were using inverse operations. So some that you may have hit in high school, squaring a number and the square root of a number. Those are inverses. Cubing a number and cube root of a number. Those are also inverses. So in reality, you already have some familiarity with this new topic that we're going to be talking about. So again, think back to middle school when you first learned how to do functions, when you first learned how to do operations using function notation, which you see right here. And you were given diagrams such as this one that had two circles. We have on the left-hand side the domain, and on the right-hand side here, we have the range. And what a function does is it takes an element of the domain and it maps it into the range. So if my function is going to be multiplied by 2, I would take 2, multiply it by 2, and I get 4. Same thing for 3. I'll take 3, multiply it by 2, and I get 6. And then I take 4, and I multiply it by 2, and I get 8. So every element from the domain can be mapped onto an element from the range. That's what a function does. Well, the inverse of that function does the opposite. It takes that element from the range and it turns it back into an element from the domain. So this is our notation right here for inverse. Be sure you write this on your paper. This f and then the -1 looks like an exponent, and then the x in parentheses just like you have here. So this is your original function, and this is your inverse. So if my original function was multiplying by 2, the thing that's going to undo that, its inverse, is dividing by 2. So if I take an element from the range of the original function, right, here's the range set, and I'm going to take that element of 4, divide by 2, and I'll turn it back into the 2 that we had to start with. Same thing with 6. If I do the inverse operation, I'm going to get, oops, not 6. I'm going to take the inverse of that, and I'm going to get 3. And then 8, if I divide by 2, I'm going to get 4. So a function takes an element from the domain and turns it into an element in the range, whereas the inverse of that function takes its range elements and turns them back into the domain elements. All right, let's see what that's going to look like algebraically. So my function that I was just looking at was multiply by 2. If I take a value of x in the domain and I multiply it by 2, that's what my function would look like. Now my inverse function, I'm going to take an element and I'm going to divide by 2 instead of multiplying by 2. All right, so one thing to notice here is when we rewrite it like this, you do still put an x there. The original function takes domain values and turns them into range values. Now the inverse function, its domain, its x values are the range values of the original function. So if I look back over here, these are the range values of my original function f, but they are the domain values of my inverse. So the function takes an x value and turns it into a y value. The inverse takes a y value and turns it back into an x value. But because we are quote unquote feeding the inverse these functions, they are the domain values of the inverse. They're the range values of the original, but they are the domain values of the inverse, which is why you see x again right here. Okay, so let's see what this looks like in practice. So f of 5, if I take 5 and I substitute into my function, 2 times 5 is 10. So the range value that goes with the domain value of 5 is 10. My function f takes the value of 5 and maps it onto 10. Okay, so let's take that 10 and substitute into the inverse. So the inverse function takes that value, that range value from the original as its domain value, and it divides by 2. 10 divided by 2 is 5. So what I want you guys to pay careful attention to is the fact that this value that I end with and this value that I start with are the same x value. Whatever my function does, my inverse function undoes it, and I end up with exactly the same thing that I started with. That's very important. All right, let's look at this one. So I have this function, 3x plus 5, and I have its inverse right here. Okay, so let's see what happens when I put 2 into my original function. All right, 3 times 2 is 6. 6 plus 5 is 11. So the value that my domain value of 2 maps onto is 11. All right, so now let's take that 11 and let's put it into the inverse. All right, without even doing any work, based on what we said last time, what value should we end up with? Okay, let's see if you were correct. Let's do order of operations here and simplify this. 11 minus 5 is 6. And 6 divided by 3 is 2. So just like last time, you can see that the value I ended with is exactly the same as the value I started with. If a function and its inverse undo one another, then you should end up in exactly the same place as where you started. Okay, let's look at this. So this notation is a little bit new. It's a little bit different. You can see that I have my function f right here, and I am going to put a function inside of that function. Instead of putting in a number like 2 or 5, I'm going to put the whole function in there. So I'm going to take this x minus 5 over 3, and I'm going to substitute it in place of that x. Okay, so let's see what that'll look like. So the 3 doesn't change. In place of x, I am going to put x minus 5 over 3. I'm going to put that whole inverse function in there, and then I'm not going to change the plus 5 on the outside. So that's what this notation means. It means take the function f inverse x and put it here in place of x. The 3 doesn't change, the plus 5 doesn't change. It's just that instead of x, I'm going to have this whole x minus 5 over 3. Okay, let's see if we can simplify this. Let's use order of operations and see if we can simplify this. Okay, so looking at this, what is the first thing that we should do? Well, I see these parentheses right here. Inside the parentheses, there's nothing that I can simplify, but I remember that parentheses mean multiply, and multiply is my next step in order of operations. So if I multiply by 3 and divide by 3, those cancel each other out. They're inverses, so they cancel out. So what I'm going to have left is x minus 5 plus 5. I don't need the parentheses anymore because I already did the multiplication that the parentheses were there for. Okay, so now let's look at this one. What should my next step in simplification be? Well, again, order of operations, I'm going to combine like terms. Negative 5 and positive 5 are inverses. They cancel each other out. And what I have left is x. So look what happened. What I ended up with is the x value that I started with. That will always happen for a function and its inverse. If you put one of them inside the other one, they should cancel each other out because they're inverses. And what you have left is that x value that you started with. All right, let's see if it makes a difference which order we do it. So look at how this changed. This one, do you see I have f inverse on the inside and I have f on the outside? Well, now I have f inverse on the outside and f on the inside. So what that means is I'm going to take that whole f of x and I'm going to substitute it in. So I'm going to take this 3x plus 5, what f of x is, and I'm going to put it here in place of x. So this time, when I get ready to simplify, my minus 5 is not going to change. My divided by 3 is not going to change. What's going to change is that this x that's here in the numerator is going to become 3x plus 5. I'm going to take this whole function and I'm going to replace it with the x that's right here. Okay, order of operations. What can we do to simplify here? What should my first operation be? Well, the first thing I'm going to do is add and subtract 5. I'm going to combine my like terms. I can't do division first because all of these are not divisible by 3. I'm going to need to do plus 5 minus 5. All right, well, you guys have been doing algebra long enough. You know plus 5 and minus 5 cancel each other out. That becomes 0. So now I've got 3x over 3. All right, so what happens now? Well, now the 3's cancel out. Dividing by 3 and multiplying by 3 are opposites. They cancel out. And what I'm going to have left is x. So just like last time, what I ended with is that same x value that was here at the beginning. Anytime you have a function and its inverse put together, what you will have as the answer when you simplify is plain old x. They should completely cancel one another out. So this operation is called composition. All right, composition of functions just means you put one function in place of the other. It's just that in our case, we're very specifically looking at a function and its inverse. You can do the composition of any two functions you want to. We are just going to focus on a function and its inverse.